Good morning. This is B.S. Rajati again with our favorite subject. Energy engineering. We are in lecture number 10 or lecture number 4 of thermal power plant, as we have started part B. Hence, this will be the lecture number 4 of, and in sequence, it is lecture number 10 today. And before that, whatever we have studied in last class, that is lecture number 9/3. That is coal handling plant. Brief about it, and then we'll proceed further today. So we have seen in that what do you mean by coal handling plant, what are the steps, or what are the we can say things being carried out in coal handling plant: coal delivery, unloading, coal preparation, coal transfer, outer storage, cover storage, in plant handling, weighing and measuring, and lastly furnace. So these are the steps, various steps. Then you can say prepare coal, finally reaching to the furnace for combustion purpose. So we saw what do we mean by sizing of coal, conditioning of coal, blending of coal. Blending means mixing of coal. Beneficiation of coal means that is a sizing, removal, ash removal, etc. That is the, and also includes blending of coal. Desulfurization means removal of sulfurization. Then we saw how the coal is being prepared in the coal handling plant with the help of this diagram. Then what are the equipments required to carry over the coal from one place to another or to the last destination? Belt conveyors, screw conveyors, bucket elevators. We saw it. Then we saw the necessity of coal storage. As I discussed this, we have to store the coal in view of the price, in view of shortage, in view of this, you can say, seasonal, rainy season, and we may not get the ample quantity of coal from the mines. You have to keep minimum storage, and that too also depends upon the space available at this site. In plant handling, then we weighing before sending it to the furnace for combustion, how much coal is being utilized, that is to be noted down. Then we saw types of furnaces, mainly overfed furnace and underfed furnace. Again, there are so many types. Then that is overfed. These are the mechanical strikers or stokers, or that one we saw spreader type and sprinkler type, hand firing. What are the advantages? Underfed stokers, we saw single stoker, retort stoker, and multi retort stoker. So this is in brief about the last class. Now today we are going to deal with lecture number, this is 10/4 on the introduction to thermal power plant. So now we're today going to see about this coal factor. Coal, as you know, is the one of the important, you can say, fuels used in the thermal power plant. There are more major 4 types of coal can be classified. A, B, C, D, you can say. Nowadays we are having E, F grades also. Rank refers to the steps in a slow or natural called as qualification, during which buried plant matter changes into an ever denser, drier, more carbon-rich and harder material. The 4 ranks are, again, depending upon this. Ranks means the type of the coal. First is anthracite. second bituminous, then third one is subbituminous and lignite. Anthracite, you have already studied. I am going to just brief it. The highest rank of coal is anthracite. It is a hard, brittle, and black lustrous coal, often referred to as a hard coal, containing high percentage of fixed carbon and low percentage of volatile matter. Means it is little bit difficult to combustion. Okay. Bituminous coal is a middle rank coal between subbituminous and anthracite. Bituminous coal usually has a high heating value and is used in electricity generation and steel making in the United States. Bituminous coal is blocky and appears shiny and smooth when you first see it, but look closer, you'll see that it is thin, alternating, shiny and dull layers. Subbituminous, this bituminous coal is plentifully available in India. Subbituminous coal is black in color and is mainly dull. Subbituminous coal has low to moderate heating values and is also used in electricity generation. Last one, lignite, the name of the city, lignite coal. Country, you can say lignite coal. Aka brown coal is the lowest grade coal with the least concentration of carbon. Lignite has a low heating value and high moisture content and is mainly used also in electricity generation. The main precursor to coal is peat. Peat is soft organic material consisting of partly decayed plant and mineral matter. When peat is placed under high pressure and heat, it undergoes physical and chemical changes to become a coal or a coke, you can say. So peat is a raw material, you can say. Coal quality can be analyzed. Now, this is in brief about coal we have seen. Coal quality can be analyzed by the two methods in the lab. One is ultimate analysis, another is proximate analysis. Ultimate analysis determines the coal element, solid or gaseous. It gives behavior of coal when heated. So the formula for this ultimate analysis, fixed carbon plus volatile matter plus moisture plus ash gives 100% by mass. So by ultimate analysis, we can find out the value of fixed carbon, volatile matter, moisture percentage and ash percentage in the coal. So in proximate analysis, this you can say volatile matter determine fixed carbon, volatile matter, and methane, hydrocarbon, hydrogen, CO2, ash content, which is about 5 to 4% in Indian coal, and moisture content about 0.5 to 40%, sulfur content 0.5 to 8%. It gives chemical elements along with ash and moisture. That is proximate analysis. By we can find out value of carbon, fixed carbon, hydrogen, oxygen, nitrogen, sulfur present, moisture content present, and ash present. By volume also we can find out the value of proximate in coal in proximate analysis. CV now is the CV of coal. You can say that can be measured with the help of a bomb calorimeter, that is calorific value. Coal gross calorific value or gross calorific value various nations is as below. Indian is around 4,000 kilocalorie per kg. Lignite 4,500 kilocalorie per kg. Indonesian coal is calorific value. Higher the calorific value, higher the heat content you will get. 5,500 kilocalorie per kg. South Africa 6,000 kilocalorie per kg. So next, combustion refers to the rapid oxidation of fuel accompanied by the production of heat or heat and light. Complete combustion of fuel is possible only in the presence of adequate supply of oxygen. Means combustion only takes place if there is excess of air or excess of oxygen. Nitrogen from atmosphere, carbon, hydrogen and sulfur from the fuel combines with oxygen in the air while combustion process to form NOx, CO2, moisture and SO2 respectively, and releasing some heat. This is about combustion. I'm just telling in brief about all the factors. Now we have already seen coal beneficiation and coal preparation in the last class. Just revise it. So coal beneficiation refers to the process through which inorganic impurities are separated from raw mined coal, thereby providing improved combustion characteristics of fuel produced. The majority of the coal cleaning process use upward currents or pulses of a fluid such as water to fluidize a bed or crushed coal and impurities. So the lighter the coal particles that rise and are removed from the top of the bed, the heavier impurities are removed from the bottom. Coal washing is nothing, again we are saying coal beneficiation or coal preparation. Coal washing is accomplished by one of the two major processes, by density separation or by froth flotation. Okay, the washability characteristic of coal reserve are provided by obtaining liberation data on raw coal sample. Okay, so this is just a coal beneficiation and coal separation, and note it can be asked, so you can write down that one. Coal blending, again repeating, blending of imported and domestic coal is becoming of increasing importance. As I told, blending means mixing of two grades of coals. Until recently, coal blending in power station was mainly adopted to reduce the cost of generation and increase the use of indigenous or more readily available coal. Low grade coal can be mixed with higher grade, that is imported coal, without deterioration in the thermal performance of the boiler, thus reducing the cost of generation. With coal markets changing, new reasons for blending are becoming apparent. Means this blending is nowadays becomes, as in you can say, must or is needed because of the cost price, and also the design of the furnace is such that you cannot burn the higher grade of coal in India. So blending is an essential factor in thermal power plants or coal handling plant. Okay, so this is about, you can see about the coal blending. Now next factor is coal selection for thermal power plant. Other factors are not so important, just you can go through later on. Coal selection for thermal power plant. The first step in selecting new coal sources is to review the fuel specifications. Coal quality parameters can be compared against the design coal. So whenever you're going to use the coal in thermal power plant as a main fuel, you must know about the characteristic quality of the coal before burning it. So how do you select the coal then? So there is one factor, HGI, hard grower grindability index. In order to evaluate a coal, its proximate and ultimate analysis you have to study, and that is done in every power plant before using it. And that just to hard grower grindability index, higher the HGI, it will be softer the coal. Lower the high HGI, it will be harder and it will be not useful. So so this all plays important role in coal selection, ultimate analysis, proximate analysis, HGI, and ash composition. But it is also worthwhile obtaining more advanced analysis data after this is the preliminary analysis of the coal. So the next step in determining the suitability is to undertake some performance testing at site. This may entail the use of pilot scale facilities. Again, one lab test you have to undergo. Drop tube furnace. It is a furnace where you can just a sample of coal is being heated with excess air and high temperature, and determine the combustion and efficiency. So you can see the quality of coal in this drop tube furnace test and emission performance test. Then if this is successful, the next step is to introduce the coal to the thermal power plant, initially at trial basis. Trial concentrated coal will be taken, which could be introduced to a single mill. There are usually more than one mill in the power plant, 3 to 6. So for initial trial, only one mill has run in the during the construction or during the project installation work. Initial testing may take a few hours to few days. A short trial such as this should be identify any major problems with the coal, such as poor emissions performance or failure to achieve full load operation. Finally, you have to ensure long-term suitability. An extended trial of new coal should be undertaken, ideally over several weeks. An extended trial ensures that issues such as electrostatic precipitator efficiency and ash deposition performance, which takes several days to manifest, are fully assessed. So this is about the coal. In short, you can say, so you have to take the first analysis, proximate, ultimate, then HGI analysis. After that, lab test by means of drop to furnace test. And after this secondary, then third step is to take the direct trial in the plant with the one mill running, so that the performance of the coal can be evaluated with percentage of ash present and percent how much is capable to draw the more and more efficient, and that is more combustibility. Okay. Coal water slurries. This is one more important phenomenon nowadays in view of the fuel utilization. The mixture of solids and liquids is called slurry. Physical properties of these slurries depend on factors such as size and distribution of the particles, concentration of solids, agitation of the mixture, temperature, and viscosity of the carrier. Water is the most used fluid, but several minerals and vegetable oils or even biodiesel or alcohol can also be used. So most of the coal slurry fuels can be separated into different categories depending upon the type of liquid used to mix the solid coal particles. For example, CWS, coal water slurry, coal oil slurry, coal oil water slurry, coal methanol slurry, and coal methanol water slurry. Among these, coal water slurry can be considered as being the one with the higher economic viability and largest commercial interests. Coal water slurry is the mixture of pulverized coal in the water, which keeps the stability in the mixture over time, mainly when additives are used. CWS can be used as a fuel for boilers, can replace petroleum for energy conversion. It is a fuel that in storage and transportation conditions is non-flammable and eco-friendly with good combustion efficiency compared to conventional fuels. Hence, you can use fuel slurries for combustion purposes. In order to obtain maximum efficiency, the concentration of solids in the CW must be as high as possible with minimum viscosity to allow storage and transportation through the pipelines. Next topic is polarized fuel handling system. Two methods are there used to feed the polarized fuel to the combustion chamber of the power plant. First is unit system and second is central or bin system. You have seen, just I will show in figure this both raw coal coming from the coal handling crusher, magnetic separators, coal dryers, coal bunkers, then they are going to the power plant. In unit system, you are seeing there is a coal scales or coal bunkers, separate coal bunkers for the separate polarizers. So there are more than 3 to 6 polarizers will be there, and each polarizer, after crushing the coal to the fine size, then it's sent individually to the furnace. This is in unit system, whereas in central system, in brief, you can see comparison. So the coal scale is there. Here is separate. Here is a bigger coal scale, bigger bunker. Then it is one. There is one centralized polarizer. You can see here individual polarizers in unit system, whereas in central system one centralized polarizer is there. Polarization takes place, then it is stored in centralized bin, and from the bin it is sent to the feeder. From the feeder, then it is sent individually to the furnaces for burning. Like this, burning action is taking in both systems like this, but only the polarization type method of polarization taking place in unit system is different than the central system. Again, we'll see in detail. Unit polarization system is each burner or group of burners. In this system, each burner or group of burners and polarizers constitute a unit. Crushed coal is fed to the polarizer through feeder. Hot air or fire gates are there, passed through a feeder to dry the coal before feeding to the pulverizer. The pulverized coal is carried then from the mill with the help of primary air fan we have studied initially. So primary air fan is used for transportation of the fine coal toward the furnace. This further carries the coal through short delivery pipe to the burner. The secondary air is supplied to the burner directly before entering the fuel into the combustion chamber for combustion purpose. Secondary fan. So advantages and disadvantages. Just we'll go. So you can see here the line diagram. Raw coal going to the feeder, then polarizing. It gets polarized in the polarizer through separator or classifiers. Then it is taken to the burner with the help of fan. It is written induced draft or forced draft fan. Then it is sent to the a primary fan. Then it is sent to the burner, transported. Okay. In secondary, advantage and disadvantage, just we'll see up later on. This just will see the central bin system. The crushed coal is fed to the dryer. You can see the crushed coal is fed to the dryer from the raw coal bunker by gravity. The drying of the coal is taking place, is effected either by using hot gases, preheated air, or blade steam. The dry coal is fed to the mill or pulverizer. Here you can see with the help of air, and it is separated in the cyclone separator. There is a cyclone separator here. Okay, the separated pulverized coal is then transferred to the central bunker. You can say this is the central bunker. With the help of conveyor, belt conveyor, it is sent to the centralized bunker with the help of conveyor. Then the central system uses practically all equipments used in the unit system with high capacity for each part. Then you can see this is sent to the pulverized fuel feeder directly, and with the help of a fan, FD fan, it is forced. The pulverized fuel is forced to the burner or furnace. So advantages: the central system is flexible and changes can be made to accommodate quick changes in the demand. There is a greater degree of flexibility. Burners can be operated independently. The polarizers can be shut down when sufficient reserve capacity has been achieved. This is the most important in the unit system. You cannot shut down the polarizers. Polarizers run 24 hours in the center unit system, and whereas polarizer can be shut down when sufficient reserve quantity is achieved in the pulverizer fuel feeder, or you can say coal bunkers. The polarizer can be the same can be used during peak load periods also. Initial setup cost is high. Disadvantage: power consumption is also high. Possibility of fire hazards. Coal transportation system complex. Dryers are essential. The operation and maintenance charges are higher than the unit system of same capacity. Polarization. What do you mean by polarization? Polarization means nothing but the fine coal. Polarized coal is the most efficient way by of using coal in a steam generator, the coal is ground so that about 70% will pass through 200 mesh, that is 0.075 mm, and 99% will pass through 50 mesh, that is 0.30. A polarized coal boiler can be easily adapted for other fuels like gas if required later without much difficulty. However, during the design stage, it is possible to make boilers firing multiple fuels. With pulverization technology, large size boilers could be designed, manufactured, erected, and run much more efficiently. What are the types of pulverizers? Slow speed mills, medium speed mills, slow speed mills like ball or tube mills, medium speed mills like ball and roller mills, and higher means high speed impact mills. We'll study some of the mills in brief. The slow speed and medium speed mills are selected for coals ranging from subbituminous to anthracite. The high speed mills are used mainly for lignite. What is the purpose of a polarizer in a coal fired boiler? To supply pulverized coal to the boiler as per requirement of steam generation, transport the pulverized coal from pulverizer to the burners in the boiler, to remove moisture in the coal to an acceptable level of firing for firing in the boiler, to remove high density in organics from coal during pulverization, to classify coal particles to the required level of fineness, normally 70%, through 200 mesh. This 200 mesh is in the coal mills and the classifiers, and less than 2% on 50 mesh. Coal parameters affecting the pulverizer output. That is the hard-grave index of coal tells us about the ease with which it can be pulverized. Higher index, I just told, the coal is easier to grind. 50 HGI is normally taken. More than, higher than is fed to the pulverizer, the output will be higher than base capacity, and below 50 HGI, the output will be lower. The total moisture in the coal has a high effect on mill output. The higher the moisture, the lower the output. Higher pulverized coal fineness increases the recirculation in the mill and the output reduces. The inlet size of the coal also affects the mill output directly. Mill airflow variations results in changes in mill output temperature and fineness as well as capacity. So in brief about this coal parameters affecting the pulverizer is the size of the size of the fuel, size of the coal, the hard grow index, total moisture, input coal size, output fineness, and mill where have direct impact on the mill output. Okay, so we'll see the 2 to 3 mills here. Ball mill, a line diagram of ball mill using two classifiers is shown in the figure. It consists of, you can see there are two mills with classifiers here. This is the drum. Okay, the function we'll see with explanation. This is the exhauster fan, two exhauster fan, left side and the right side. These are the coal feeders from which the coal is fed to the coal mills. And then there you can see left side burner and the right side burner. Okay, now you will get it idea. So it consists of a slowly rotating drum. So this is a slowly rotating drum which is consisting of partially filled steel balls are there. Raw coal from the feeder is supplied to the classifiers. From here it moves to the drum. Classifiers to the drum. Then it by means of a screw conveyor placed inside, not shown. As the drum rotates, the coal gets pulverized due to the combined effect between coal and steel balls. Hot air is introduced into the drum. The powdered coal is then picked up by the hot air and the coal air mixture enters the classifiers. The lower size or where sharp changes in the direction of mixture throw out the oversized coal particles. Oversized coal particles fall down and the sizes, the fine size part, the oversized particles are returned to the drum and the fine size goes to the burner. The coal air mixture from the class moves to the exhauster fan, and then it's applied to the burners for combustion purpose. So you can see the fine pulverized coal is then taken from coal mill to the burner with the help of fans. Now then about ball and rest mills. In these mills, again just I will explain the diagram first. You can see there are two springs, adjustable spring here. You can see this rotating classifiers here. The classifiers is rotating. This is the raw coal feeding from both ends. This is the stationary upper rack you are seeing here, and this is the lower rack. And in between this upper and lower rack, the balls are being placed. Lower racking is rotating with the help of worm and worm gear, with the help of motor. Okay, so slow speed is there. Then this hot primary air is being supplied to both sides, left and right side, you can say, into this race. Okay, what happens, you now just see. First I explain this figure, and then now in this mill the coal passes between the rotating elements again and again until it has been pulverized to desired degree of fineness. The coal is crushed between two moving surfaces, namely balls and the races. The upper is the stationary race, and the lower mentioned, the lower race is rotating with the help of worm and worm gear mechanism. And the raw coal supplied falls direct on the inner side of the races. Okay, the moving balls and races catch the coal between them and crush into a powder. The necessary force needed for crushing is applied with the help of springs. So you can adjust the springs so that necessary crushing can be achieved in the races and balls. The hot air supplied picks up the coal dust as it flows between the, so hot air, what it does, the fine coal particle passing through the coal classifier again, fine particles, it allows the fine particles to flow upwards, and the heavier particles fall down again. The hot air supplied picks up the coal dust as it flows between the balls and races and then enters the classifier, where oversized coal particles are returned for further grinding. This is about ball and race mills. Then last one, which is widely used, we have this ball mills in 250 megawatt, where I was not working there, but we have seen that ball mills, and also I have seen this bowl mills in 210 megawatts in number of times, and its operation, maintenance, etc. also seen with the help of my colleagues. So this is my most widely used mill because it is a very nice one in working, and its main function is it can change over if it is done, it can take load immediately. The most widely used mill for grinding coal, the raw coal is fed into the center of the mill. The feeder, from the feeder it is coming to the mill. Here there are rollers, 3 rollers are there. In the figure you can say cut section, you are seeing only 2 rollers. These 2 rollers are set or adjusted with the help of spring mechanism, so that there will be a gap, minimum gap between the roller and this stationary, you can say, race, or it is grinding table. So when the coal comes in this between roller and this grinding table, crushed to the size, fine size, then this fine coal flows in the upward direction through the classifiers. You are seeing these classifiers here. So fine particles are then moving towards the, from the central pipeline, you are in the raw coal feeder, raw coal or coal from the feeder is being fed to the mill, and from the other pipelines, the fine coals is taken to the furnace with the help of primary air through the pipelines at all corners, 4 corners of the furnace. It not only 2, means for the mill there are totally 4 outlets and 1 inlet. Through 6 elevations were there, so 6 pipelines for each pipeline. So A, B, C, D, E, F elevation of the furnace, and 4 corners So it is going to four, you can say 4 corners. It is going to the 4 corners of the, maybe, yes, 4 corners, sorry, 4 outlets and 1 inlet, and then it is being carried to the all corners up particular elevation. Suppose there are 6 mills, means A, B, C, D, E, F. So there were 3 elevations of the furnace: AB elevation, CD elevation, EF elevation. For AB elevation, the coal from A and B mill, 4 pipelines, 4 corners. So total 8 pipes between A and B elevations. Similarly, CD, 4 into 4, 4 plus 4, 8 pipelines, and EF elevation 4 plus 4, so that the amount of coal flows through this as per demand or load, you can say, or accordingly steam generation takes place in the furnace. Advantages of this polarized fuel: any grade of coal can, this is most important, any grade of coal can be used. Rate of feed of the fuel can be regulated properly. Higher capacity to meet peak loads. Complete combustion of the fuel takes place. No ash handling problems. Free from clinker problem. Free from erosion. No moving parts is subjected to high temperature. Less furnace volume is required. And this we have seen practically. Okay, these are achieved advantages. But disadvantages are high initial cost. A lot of fly ash is in the exhaust. That is there. Possibility of an anti-explosion. An explosion is more, yes. And this was happened. We have seen not on our plant, in other power plants. Skilled operators are required. Yes. Separate coal preparation plant is necessary. Yes. Nuisance is created due to the emission of fine dust. Yes. So these are the disadvantages of coal mills. I don't go in detail again, because practically we have studied these coal mills in training also we have studied. So this is the coal mill where is in nowadays used widely in almost all power station. With this topic of this coal, we have studied what is the coal type. We then see just to systems, coal blending, coal selections, coal beneficiation, coal classification, coal quality, etc. We saw in this slide in this particular lecture. Now I stop here for that today. Thank you. Thank you very much.